So my talk today is about using JUCE. Well, I don't need to sell JUCE to this crowd, but Faust maybe. So Faust is my sell here. Well, actually, I just want to tell you what I'm doing and why. And so I don't need to explain JUCE, but and you've seen Faust in a few talks already, so I don't really need to explain that either. So what I'm going to talk about is how I integrate it and why I'm doing it that way, and some interesting experiences along the way that I want to relate. So I'll talk a little bit about Faust. Does this thing have a pointer? Oh yeah, there's a pointer. Wow. So except that it's kind of wild. So I'm going to talk a little bit. I'm going to go quickly through Faust and then how I integrate in Faust and JUCE. I'm happy with it finally. I had to think about it a bit, and then and some interesting attempts at using ChatGPT to do some of that. So I'll show you that. So everything I'm saying is motivated by this one goal. Okay, it's how do you develop C++ as fast as possible? You know, you want to just get it done now. So you want to write it, and you want it to be right, and you want to move on to the next thing. And so for me, the answer to that really is to write it in Faust by hand. And I get a solid order of magnitude speed up over just writing C++. Now, part of that is that I'm not a great C++ programmer. I'm still on the learning curve. You know, I'm getting better. ChatGPT is helping with that. And JUCE helped me with that. Thank you very much. Thank you for the excellent practices that I learned from. And so, but even though I'm, getting there, that I don't have to look up at everything when I write, it's still faster, and I'll try to explain why, to write in Faust. So ChatGPT, I gave it a chance. It is not faster than writing in Faust because it doesn't know Faust well enough, and it doesn't actually know JUCE well enough either. It knows C++ really well, and if you start writing signal processing code in ChatGPT, it just is out of its depth. It actually just doesn't know very much, and so you get really toy implementations, sometimes just completely wrong. It's just not there yet, but for general purpose C++, it's very good. So the things that I've noticed that it's really deficient in is elementary signal processing, especially if it gets into complex variables. It knows something about everything, right? It can talk about it, but when you give it a problem where it's got to set up an integral and solve it, it needs a lot of coaching, and I try to make myself coach it through to the end so that they'll have the training data. I think the human reinforcement feedback reinforcement learning human feedback. I think it is giving us a lot of weight, so I'm believing that and spending the time. But the bottom line for getting the signal processing written is writing it in Faust by hand. That's the current winner. This is just a screenshot of the Faust IDE, the integrated development environment. That is. It's a lot of fun. You can hit play, and this is the block diagram automatically drawn by the compiler from the code here, and you can select the DSP and see it running and get your GUI primitives and try them out on a sound file that you can loop, or you can play it from MIDI in the keyboard. So it's a great environment for prototyping and getting things working and learning about it. Oh, and I should mention you can pop up all the examples and take a look at all the libraries up there. So I just wanted to mention that as a good entry point. And I'm going to breeze through this overview because I think you've seen some of it, and you can, mainly I just want to say it's a really great domain-specific language for specifying block diagrams. And so you're not programming samples, you're programming block diagrams. You're slinging signals. So you're writing in terms of signal processing at a higher level than samples. And I think that's really a huge acceleration. You don't have to do any allocation. You don't have to do for loops. You can't really do for loops. So it's no debugging on the sample level. And this is the key. When it looks right, it's usually right. You look at that block diagram, and if those blocks are tested and you've built something, it doesn't matter how big. If it looks right, it's probably right. And this is basically where I get my order of magnitude. And another thing about Faust is that it'll generate all these languages. So, and more than these, and includes some good embedded options as well. And so I mentioned the GUI primitives, and so we'll see those again. And the way you bind a general purpose Faust program into a particular environment is by means of architecture files. So you can think of it as kind of a standalone program or plug-in that you then insert. It has hooks in it for the compiler, the Faust compiler, to insert the general purpose C++ that it generates. And so there are many, many architecture files for reaching all these platforms which is really great. You know, I'm normally on Mac or iOS, but you can also go to these embedded options down here. VZP Rack, there's really quite a lot of nice options. Now, this is an example I like just to show you the generality. So here's this one-liner. So process is the only required functional programming language, so you've got to specify the function process. And so in one line with these definitions, you can specify a completely general state space model. So that's the general causal linear time varying system. And so each of these matrices, these 4 matrices, can change every sample. And here's the initial conditions if you have them. And your state variables are these feedback delays. So you get a delay automatically when you feed back a signal. So those are one sample delays, and that's where your state variables go. This is a completely general linear time varying network, anything you want. And of course, you can also do nonlinearity. So you can saturate the outputs and put sigmoids in there and switches and all that sort of thing. So we've already seen the mini-mug. I thought I'd throw it out again. This is the QT interface that's used. Totally standalone Faust. This is a Faust standalone app. You just say Faust to Core Audio QT in this case. And so you can see the 3 oscillators and the voltage control filters, the contour, you know, the envelopes and the usual things. The switches are all there, and even the feedback from the output to the input. So it shows you how much you can do, more or less, with the built-in GUI primitives of Faust. Horizontal groups of vertical groups of horizontal groups, etc. And there's all these knobs are either horizontal or vertical sliders, and if they get long and skinny, they pop into the right orientation, that sort of thing. So, so integrating JUCE, well, the easiest thing you can do is just run Faust to JUCE. That's a bash script. And you, what it does is just use the right architecture file and spits out a JUCE project. You know, you just open Producer, build it for Xcode or whatever you want to use for your IDE, and build your standalone plugin, and there you are. And so it looks a lot like the Faust Core Audio thing, but it's got your JUCE look and feel. You know, you're in JUCE, and at that point you can take it over and do whatever you want. But there's one more level that you should consider, that I had to consider, and that is, while the standalone apps are great for initial testing, and the script will get you into JUCE, you can't bypass pieces of that. So that all those oscillators and filters all running at the same time, and if you're not using 1 or 2 of your 3 oscillators, you're still paying for it. Your CPU is still running. And so if you need to bypass pieces of it, then you're going to want multiple modules. And so you normally would have like an oscillator.h that's generated from oscillator.dsp. So it's a standalone Faust module, just doing an oscillator, nothing else. It's sort of your minimum runnable unit. And then you instance that as many times as you need in C++. And so you do that for all your modules. And then you do any bypassing in C++. You know, if you don't run it, it's bypassed because all the processing is in place in JUCE. And so another reason you might want to do something more than just Faust to JUCE is to take over the GUI. And so I'm told that most people just really write it directly in C++ using the paint function. You know, just write their own paint function. That's a lot of work. And I like Nick, I heard about the WebView-based GUIs coming. So we're looking forward to that. That'll be great. And my own GUIs are really just research prototypes. I don't really want to spend any time on them. And so if I could just translate the Faust GUI, I'd be really happy. And I was actually quite happy with the GUI Editor in Producer, but now that's deprecated, so looked around for something else. And I also found that plugin GUI Magic was nice. And Daniel Waltz's system is really nice. Here's a screenshot of it. You saw it earlier today. So there's the editor on the left, and you can, you know, this is basically your value tree here for the GUI, and you can select something and set its properties and hook it up to parameters, and that's all you do. So to integrate your Faust into JUCE, all you have to do is define an audio processor parameter wrapping each DSP parameter, each Faust parameter, and then once you do that, it'll be here in the menus. You can just, you know, dot it up and hook it up, and life is good. So Faust parameters are different than JUCE parameters. In the Faust world, the Faust parameters live in the DSP module, essentially the slider state. So every time you drag out a GUI element, that provides a kind of a controller interface, and it's got its own state variable, and it's in the DSP module, not the interface. So when you make an interface, it just gets pointers to the state variables. And so you can have any number of interfaces, and they're just all pointing into the state variables of the DSP module. And so another interesting difference is that the parameters are all Faust float, and those usually just float, and they're assumed atomic in hardware. So in JUCE, you'll see standard atomic pointers to the parameters, but in Faust, it's just use atomic hardware primitives. So on a 32-bit machine, you expect 32-bit float to be atomic and so on. And I'm told that ARM and Intel have this worked out and we're okay. And I've never run into an issue, but it's something to know. So in the JUCE world, you'll have your plug-in parameters. They have to be in the audio processor because the editor is optional. And then if the editor is up, then it will have its own copy. And they have to keep, they have to synchronize each other. So they use listeners primarily for that. So each GUI element has listeners, parameters have listeners, and a GUI element will attach to a parameter, and the parameter will listen to the GUI element. And so that's the pattern there. But I was really happy to learn about the raw parameter pointers. This is very much like Faust, and if you use these, you can basically use the same kind of parameter scheme, and they can be brought together very efficiently, and that's what I'm going to show you now. So the question, though, I had was, can we get it down to 1? So can we make the audio processor parameter raw pointer to the parameter refer to the DSP state variable? Wouldn't that be slick? Because then you would have exactly one instance of that parameter. You wouldn't have to synchronize anything. It would just, if you change it, everybody gets it, and make it standard atomic. So I asked ChatGPT, can I do that? And so I had set up a little context, and then I said, can I make my JUCE game parameter refer to a pre-existing memory location? And it says, yeah, you can do that. You just create your own custom parameter class inheriting from ranged audio parameter and override these methods. And here's an example. And the example was very good. It did not quite run, but it had to be finished. And but it was a good idea. I mean, I thought it was the right answer. As far as I know, it's the right answer. I got the people here to correct me if I'm wrong. And it was very simple to take a look at the audio parameter float source and finish it off. And I think that's the answer. So do we do that? Is it worth it? And I decided it's not worth it because of the atomic float star raw pointer. You can refresh just when the parameters change, such as a MIDI controller event. MIDI controller, if you're in a high performance MIDI pipeline, you're probably just running from MIDI, right? Because those are the ones that are time stamped. You get them with your audio buffer, and you want to come in and update parameters, and then those parameters want to get propagated instantly on the audio thread. No thread switching, please. And so here's some pseudocode to just illustrate that. And really, you can just look at the synthesizer voice to see essentially the same algorithm. You just basically run. You go through the MIDI messages and see if the timestamp is in the future, and if so, you compute audio up to that time, and then you execute that MIDI message, or propagate it out. And it will then possibly change parameters. And if a parameter gets changed, then you want to propagate that forward to the DSP module. And so here that is. So it's just a standard atomic writes Faust float. And that's a negligible amount of work compared to just processing the MIDI message. If you go down into that, you see gestures, beginning and ending, and notifications and so on. So that's good enough. I think we're done. Okay, so that's high-speed integration, no wasting, no messing around, right? So for the last usage of AI to get from Faust to JUCE, I encountered a situation where I actually needed to translate Faust as a language to C++. Even though Faust compiles to C++, I needed to actually translate it. And there can be some reasons, for example, to add SIMD. There's no SIMD support as far as I know in Faust. And but the case that I ran into was I needed to convert the pattern matching macro arguments. I think of them as macro arguments. They just have their compile time constants that get manipulated by the pattern matching system, and they have to be known at compile time. They're not changeable at runtime. And so I needed that because I needed the filter design primitive to run at any order. I needed to be able to instance a filter at any order because I needed essentially all orders up to 50. And so I didn't really want a giant array of precompiled Faust modules for each and every little order constant, right? So I just wanted to change it to C++ so that I could have a constructor that had that order. I don't mind it being at construction time, but I need it to be, at least that. And so can I rewrite the low-pass primitive, which is Butterworth, in C++ using ChatGPT? And the answer is yes. It was actually quite easy. And I was using 3.5. This was before 4 came out. And it got me almost all the way there in one iteration, but it was funny because it didn't really know Faust. It was really just kind of translating functional syntax from Faust into C++, but it was helpful. It was helpful. And then later, and I also converted all the comments to Doxygen format, which was helpful. So it was really happy. And then I also had good luck, better luck actually, going from MATLAB to Python or MATLAB to C++. So those translates, if it knows the language really well, you're going to have better luck. But it's a good translator from any language that it knows to any other language that it knows. And so it also writes decent unit tests. So the conclusion is it works. And what we need now, though, is JUCE GPT. So in my last 3 minutes, I want to emphasize that. So just, get something, Copilot, get over what you want from Amazon or Google or OpenAI and fine-tune it on the latest JUCE distribution and all the updated examples, and life should be really smooth at that point. And so next Saturday is Faust Day at Karma, and I'm giving a talk. I'm going to go more in detail about this Butterworth to C++ translation, because there were some really interesting things that I observed. And I'm going to go, I have an hour-long talk there. I can go farther. And it's free online and in person, and there's a link here that should work in the overheads if you grab them. And so just to summarize or conclude, the ChatGPT 4 is really useful for general purpose C++ development, not signal processing development. It's good for any well-known language translation. The quality of the model seems to be proportional to the amount of data that hits that case in the latent spaces. We know this since the LMS algorithm in signal processing. It's that it's the data that drives the convergence of the weights in the model. And so that's a billion-dimensional, hundreds of billions of dimensions, and you've got to go push all those little corners of the latent space forward with training data, or else they're going to be dark, and who knows what you get. And we enjoy that too. And it's also been writing unit tests, but in signal processing, you have to debug them quite a bit. In JUCE, you have to debug them quite a bit. Formatting comments is just great, and there can be more. And I can see I'm down to my last minute, so I will leave you with a limerick. So I asked, write a limerick about JUCE. And I had to edit even that. So you hear my edits for the human feedback, reinforcement, learning, improvement. If you disagree with my edits, then let me know afterwards, and I'll submit a correction. So I think I'm actually on time. So more on Saturday. I'm trying to find that link. Actually, it's cached. Any questions? I guess we have 2 minutes, 1 minute for questions.
Is ChatGPT any good at SIMD?
Yes. I've.
Say that again.
Oh yes, is ChatGPT any good at SIMD?
Yes, I've had very good luck, just introducing SIMD into my code with using ChatGPT to get it started, and it knows about all sorts of header files that I don't know about. It's just a great way to get started on something like that, and it will alert you to various distributions. You can see the header files that it's bringing in. You can search for them, and before you know it, you're in all the right doc. So it's a really good first thing to do. Is just ask ChatGPT. I leave it open all the time.
Hi. So I'm a big fan of using ChatGPT when I'm coding. I think it's really interesting to generate boilerplate. But one of the things that it does is kind of push the impetus from you writing the code to you reading and auditing it.
Yes.
Like, have you come up with, I know this is a super new idea, but have you come up with any ways to verify correctness? Because obviously it hallucinates and goes off the rails a lot, but the boilerplate part is a real benefit. Have you come up with any solutions to verifying correctness and not falling asleep and allowing some bug through?
Well, the two things, I run it and debug it, and I usually have to do a fair amount of debugging, and I make it write its own unit tests. But of course, I have to debug those. So, but at least you get a lot of, and you can really, see that the coverage is good. So you can try to get 100% coverage, unit tests, and once they all run, you can see what they're trying to do, and they're reasonable. And after a fair amount of flailing around, it's good, solid code in my experience. And of course, you understand everything and can read it. And if I don't understand something, I learned some C++. I learned about the raw string literal beginning with capital R that way. I asked it to create parameter layout for me because, I don't want to write 2 screenfuls of code just to get my parameters. I wanted like an old Music 5 computer music style notation that was like 5 lines, right? And so I tried to teach it as an example. Take this little terse description and turn it into, 2 lines of audio parameter float instance. And it wrote me a program that accepts my syntax in a raw string literal at runtime. So I will never write another create parameter layout again. I will just give it that string, and it returns the layout, and I'm done. I'll never have to see a page of code for 12 parameters. So I was so happy with that. I did the same thing in 3.5, and it just wrote it. It wrote it, as you would expect. But in ChatGPT 4, it gave me a language translator, or a syntax or a macro processor, whatever you want to call it. It's really, really very nice. So you have to work hard, but when you look back on it, you've saved at least twice your time, I find. And if you're lucky, 10 times. It's a 10x speed up. And people are talking about 10x programmers, and I think that's where we're all going. We're all going to be 10x programmers pretty fast. It's going to be good.